In this short video, I will show you how to conduct a test of equality of variances from two populations by using Excel. Our data is recorded in Excel, and sometimes you will have this data in one column. In that case, you have to separate them out per group. What we have in here, we have the exam grade scores of two groups of students. One group is classified as the one reading a lot of books versus not good readers. And now we are going to conduct an F-test using F distribution, and our null hypothesis is that the sample variances are equal from two different distributions. The alternative one, which is a two-sided test, saying that they are not equal to each other. They have different variances. Our F statistics is nothing but the ratio of sample variances. And we're going to conduct a two-sided test. And in this video, I'm going to use a 5% type 1 error. Level of significance is 5%. And depending on the p-value, or alternatively by looking and comparing F critical value with the F statistics, we will decide what to do, whether reject or fail to reject. There are several ways to test this. I'm going to show you three in here. The easiest one is f.test function in Excel. You can just calculate the p-value right away. You can do it manually. Not recommended, but you can do it. And also the third one is the built-in Excel function, ftest to sample for variances in data analysis toolpack. Let's start with the ftest function. If you just type in ftest, what you need to do, you just put the data range, and you don't have to worry about like number of observations in each group. Automatically it will calculate it for you, and based on the degrees of freedom, they will just give you the p-value. This is the p-value for two-sided test. It is 0.344, and since p-value is bigger than 0.05, we fail to reject a null. It's a quick conclusion. We fail to reject a null. Again, we don't have any information about critical value, F statistics. You just get the p-value. Quickly, now we don't have evidence against the null that variances are saying. So we cannot reject the null. So we conclude they come from two different distributions with same variance. Alternatively, you can calculate it manually or with Excel's built-in function. Let's do them one by one. Now, manually, what I can do, I can first calculate the F statistics. What is my F statistics? Oh, this is the ratio of sample variances. So I need to calculate the variances in here. I'm just going to put variances in here and calculate sample variance by using the var.s function. This is the sample variance for the second group, and I do the same thing for the first group with var.s function. Now we have the variances. Seems like a significant differences, but are they statistically different? Now let's calculate our F statistics first. F statistics is the ratio of sample variances. Recommendation, always put the higher variable in the numerator. It will be easier to calculate the p-value in the F distribution. So what I'm going to do, I will get the higher variance in the numerator and the lower variance in the denominator. And this is going to be my F statistics. This is F statistics, and this is the formula to get the F statistics. But now I need to decide on the degrees of freedom. Degrees of freedom on the numerator is going to be n minus 1. This is the second group. I'm going to call it n2 minus 1. And degrees of freedom for the denominator, how about I will put it numerator, degrees of freedom for numerator. This is the one that we put on the numerator. N2 minus 1, and this is N1 minus 1. So how many observations we have? You can use the count function. Again, this is manually. It's going to take a lot of time. So I have 11 observations in the first group, and by using the count function, I have 18. So as a result, my degrees of freedom will be 11 minus 1, 10, and 18 minus 1, 17. These are my degrees of freedom numbers. So I will say df1 is 17, and degrees of freedom 2. Again, 1 refers to the 1 on the numerator, and the 2 refers to the 1 on the denominator, which is going to be 10. So I have f statistics. What is going to be my f critical value? Okay, now I will just moving in here. What is critical f value? So what we're going to do, we are going to use f inverse function. So this is, I will just first show you what we're going to do in here. I got our f statistics, and since I already intentionally put the higher variance on the numerator, so what I'm going to focus on, right tail and find this rejection region. So this is going to be the area f alpha and degrees of freedom 17 and 10. So if I have anything, a number in here, I will say equal variance. And if on the other hand, my f statistics is to the right of it, this area, I will say not equal variance, not equal. So the point is, how am I going to calculate the f critical value? So we're going to use f distribution, inverse function. I'm going to delete this and come back here. Critical f, we can use f invert function. Since I'm focusing on the right tail, I will just, for the probability, I'm going to just put 0 point. This is going to be the area to the right, and since it is two-sided, to the right I should have alpha over tau, which is 0.025. As a result, I will have 9.75. And my degrees of freedom, first one is 17, the second one is 10. And I close the parenthesis. That is going to be my critical f value. Since f statistics is less than critical f, we fail to reject. Okay, this is manually, you can do that. I know it is taking a lot of time, but there is a better way of doing it in Excel. What you need to do, again, this is the manually, compare f statistics with critical f value. Now, the third option is to go to data analysis, and I have f-test to sample for variances. I click on that one. Now, this is crucial. For the variable 1 range, you have to use the data with the higher variance. That is why what you're going to do, you're going to select the second group in the numerator, and the other group will be in the denominator. I did not select the labels, so I'm not going to check the labels. For alpha, I'm going to put 0.05. I think the default is there. Somehow it's not showing up. And I want to have this produced in here and click OK. So it will give you the f-test results. As you can see, we have the variances already calculated in here, 193, 193. The second one is the one with the lower variance, and you see our F statistics, 1.801, and if you come back here, you will see that this is our F statistics. It is already calculated for you with Excel. Like if you don't go with the manual option, go with the built-in function. Now, as you can see, degrees of freedom 17 and 10. We already show you there, 17 and 10. These are like whatever the number of observation minus 1 for both groups. And here's the thing. Excel F-test shows only one-sided test for whatever reason. No one knows. This is not going to help us. But there is a better way of doing it. You can get the p-value from one-sided test and multiply by 2. Like p-value for two-sided test is going to be equal to 2 times p-value for one-sided test. So as a result, I can say that p-value is equal to, I'll just write it down in here. I'll go and get the p-value from one-sided test. I'm going to multiply by 2. And I will get my p-value. If you remember the same p-value in here, right? The F-test will give you that p-value, and we have the same p-value in here. So you can use the one-sided test and get the p-value and multiply by 2. And then now compare this p-value with the level of significance, and you come up with the same conclusion, right? Since p-value is higher than alpha of 5%, you fail to reject a null. That critical F is for one-sided. It is not suitable for an analysis if you do two-sided test. But if you do one-sided test, then you can easily just use that output and then reach out to your conclusion. In sum, I show you 3 different ways to test the equality of variances. The first one is the easiest one by using the F-test function. You just, it doesn't matter which one you enter first, automatically you get the same p-value. It is the safest one. But if you want to know more about critical F value, then you may need to go with the built-in function. And also I show you manually how you can do that. You get the variances, get the ratio, get the F statistics, and calculate calculate the corresponding p-value, critical value, and then compare with the F statistics. This is the formula. Let me write it down to get the critical F manually. Okay, that's it. Thank you for listening.